Let's get started then. Hello, everybody, and welcome to Source Talks on Scala. If you're not familiar with Source Group International and our brands, we are international recruitment specialists specializing in tech and life science recruitment. At SGI, we're on a mission to achieve the highest level of customer service, driving sustainable improvement and investing in our people. Source Talks community is a global community bringing together experts and leading professionals to discuss the challenges and changes they face across their organizations. Through our meetups and media series, we're pulling back the curtain to technology and talent attraction and building a powerful community of people on the same journey looking to achieve similar objectives. Without further ado, I'd like to hand over to my colleague Francis to intro our talk today.
So thanks, Imogen. So without further ado, I'd like to introduce Marcin Krykowski, a veteran speaker across the Scala speaking circuit. He will be diving into today about how we can employ Scala web libraries to help us achieve more by doing less. So without further ado, take it away, Marcin.
All right, thanks, Francis. Let me know if you can see my screen and if you can hear me well.
Yeah, perfect.
Lovely. So I'm not sure about you guys, but mostly at my day-to-day job, I don't have to invent compilers or create new IO monad. But what I do instead is I'm mostly working with some microservices that either talk to each other, communicate through things like Kafka, message broker, or HTTP protocol in some cases. Maybe it integrates with some other API. I have to create docs for this. Maybe add some metrics to monitor those services, and basically deploy to production as soon as possible to have this feedback. So in today's talk, I wanted to talk to you about a few things. So there are often questions asking if Scala ecosystem is actually ready for building a robust and services in a fast way, because we want to do the agile development, and we also want to compete with things like Spring. We want to compete with things like Ruby, where you can in a matter of seconds deploy a new service to production with some basic endpoints, consuming some API, with things like JSON deserialization and serialization working out of the box. Other things that we do on a day-to-day job. So the question is, like, what libraries do we have? Is there like only one that we have to commit to? Like, what can we do with those libraries? If we will go in one direction, can we like easily change this? What if we quite recent situation where Lightman announced those ACCA pricing? How can we migrate from one thing to another? How easy it would be? Does it mean if we will go with that library or like that approach, we'll have to stick to this forever and pay some crazy money? And also, like, how fast can we write business code? We don't want to write boilerplate. There is no time for this in modern software engineering. So like, before I even start creating new rich service, which will do some of the mentioned things, I often need to ask myself a question, like whether Scala will be a good choice for this. Will I be able to easily do all the fancy stuff, yet having the truly functional programming approach with all the things that and all the benefits that FP brings? So on this picture, you can see people that are building open source libraries, that are enriching our ecosystem, that are bringing the power of FP to the industry, that are creating some new effect type systems, all the fancy stuff that I use. And this is me. I'm a simple guy who tries to build stuff, trying to glue together all the pieces from different ecosystems, having some services that do really basic stuff, nothing fancy, but I just want to get the job done as soon as possible. So who am I? just a brief recap of what I've been doing. So I have 6 years of experience, out of which 3 years I've spent with Scala. I'm a freelance software dev, so I'm working as a remote contractor mostly. So that's what I do daily, and nightly I'm doing some pull requests to open source libraries, and also trying to write, blog, speak at various meetups and conferences. All right, so let's think what we usually need when we think about oh, I will create a new service. So in this talk, we will mostly focus on the API layer. What can we have there? What we want to have there? What's doable? And how easily we can put the big pieces together. Because at the end of the day, we want to have this big puzzles, big blocks, big building blocks that we can use at our job. So we will usually want to create some API. So we want to declare our endpoints. We'll have some codecs and serializers, no matter what with what kind of entities we will work. We want to send them somewhere in some kind of a format, whether it will be gRPC, whether it will be JSON or XML. We want this all to be type safe. We will usually want to add some middleware. Maybe it will be authorization, maybe it will be some logging metrics, or maybe tracing ID if you do this. We want the code to be easily testable. We want to have different integrations, because if we will be using this library one day, what if we or someone from our team will decide that we want to make a shift and we want to make this library doing the job. We will usually want to have the functional error handling, so we don't want to our service blow up somewhere in the middle. We most of the time want to have a decent performance, and maybe in some cases gRPC support, WebSockets, and obviously last but not least fast deployment. So we will focus on a few things today, which are API description, HTTP server. So we want as soon as we have our API, we want to put this into our HTTP server. We want to use we want to serialize and deserialize our entity. We want to have docs that will be working out of the box. So we don't want to each time change our YAML file or JSON file just for the sake of exposing this to the Swagger, or of having documentation laying somewhere. We want this to be as close to the code as possible. We want this to be testable. We want to have metrics. So we want to have we want to see what's going on in our service. How many requests are we serving? How fast are we responding to some requests? And we will have a look at HTTP client, because we know that we will integrate with some other services that we'll be using, and we will be using HTTP protocol to communicate with them. So there are plenty of options for the servers, and obviously not everyone is the best choice, and I think not everyone is as bad as you can think. So in this talk, we will mostly be focusing on type level ecosystem. So the natural choice here will be HTTP4S, because it easily integrates with CATs effects, and the IO monad coming from that type system. Obviously, if you want, or if you decide, there are like plenty of other options, but we will not be talking about this during this talk. Maybe briefly about HTTP and Zio, just so we know that they exist, and we can work with them as well. Okay, so HTTP for us, I bet most of you knows this, is typeful. So basically, what it means that HTTP for us servers and clients share an immutable model of requests and responses. Standard headers are modeled as semantic types, and like entity codecs are done by type classes as well. It's functional, so the pure functional side of Scala is favored here. So it promotes composability, easy reasoning, and IO is managed through cat effects, as I have already mentioned that. It supports streaming, so it's based on FS2 library. That provides things like easy payload emitting in constant space, and it also implements WebSockets if you need them. And it's also cross-platform, so it cross-builds for Scala.js, Scala native, and it shares the code, easy to deploy to browsers, Node.js, and the JVM in general. Okay, so for the basic stuff, you don't need any configuration. You don't need to configure your bean or whatsoever. You just put this couple of lines in your SBT file. So we just have to define which kind of backend you want to use for the server. We will use HTTP4S DSL that comes with some rich and handy DSL that will allow us to write readable code for our HTTP server, and some CRC integrations. Okay, so I've chosen the Blaze server here. There will be a slide with Ember as well, just to show you that it works. But if you want, there are like plenty of backend integrations over there available for that library. Okay. So before we start, we'll need some basic domain that will help us operate. So I've chosen the one that most of us know, and it's like easy to read. We have a book, we have author, and we have two services that will help us and will serve us as a business logic layer. Okay, so what it means, this request ROF option response. So in the functional jargon, it's called glycine. And what it basically means is that for HTTP4S, functional server is a function from a request to a response. But obviously, not every request will have a response. That's why it's wrapped inside of the option. And those responses for those requests that will have actually responses are effectful. So they do things like they talk to another microservice, they maybe do some validation, they talk to database, they talk to any other storage whatsoever. That's why it's all wrapped into effect type F. So yeah, as long as we have HTTP4S DSL in our project, we can easily define routes for our application, and it basically is a tuple. So it's like a partial function of a tuple, where the first part of the tuple is the HTTP verb, and the second one is the actual path. And we map this to be a response. In this case, all we do is we wrap response from the author service into the OK, which comes OK response, which comes obviously with predefined header, correct status, all the basic stuff that we need for a HTTP response to be valid. Okay, so what happens if we need to do a bit more complex stuff? So assume that we have some query parameters in our path, and we want to use them. So for the basic thing, like author in this example, all we have to do is to extend a class called query param decoder matcher. It's the author in our example is just a basic string, so we don't have to do any mapping. In case we want to, for example, do a bit more complex thing, which is we want to have a year in our path, and year cannot be any integer. We have to validate this before we will let this into our system. We have to create like a custom implicit for this purpose, which will be query param decoder. And then once we have this in our implicit scope, we just define our optional validating query param decoder that can be supported by our path. Okay, so here's the example of what I have just mentioned. So the first thing the first route you should be already familiar with. With the second one, what we do is like we check two params. The first one is author. The second one is maybe year, because we don't know whether this year is whether the value provided in the path is actually correct. So firstly, we fetch some books for this given author. Then we do a pattern match on the year. Depending on the outcome of this pattern match, we either filter books written by this author and in that year, and we return and yet again we wrap our response into OK response, and we do two interesting things in that line. So we actually call as JSON, and as JSON allows us to seamlessly define a JSON. So as long as we have defined our entities, we have either decided to use Circe or any other provider, in this any other JSON serializer. In this case, I have decided to use Circe. All we have to do is to either define the automatic or semi-automatic derivation for those entities, and then we can call as JSON method inside of the OK response inside of the OK wrapper. So we transform our entities, our books into readable JSON, and we also add the custom header in that example. In case we didn't receive any error in the as the parameter, we just use books fetched for this author. All right, so we have our routes defined. What should we do next? So as easy as it looks, we only have to provide definitions of our paths if we want to add some versioning, or maybe add some different routes for those predefined routes. And then as we have them, we can call not found to indicate that we will not have any other. We'll return 404 for path that is for the endpoint that could not be found in our application. Once we have this, we have to build our server, and we do this by defining some port, host, defining routes. Obviously, we have to provide custom runtime. And yeah, we just indicate, because this is like a catch resource, we indicate that we never want to close this resource, so we want to keep going. Okay, so obviously we don't only work with gets. We don't only work with get requests, but creating post, put, or delete is easy as well. I have a little helper method called book result here. But other than that, in the for comprehension, you can see in the first example, you can see decoding a JSON that comes with the request, creating a book in the repository in my storage, and then returning created with a JSON of created book, and location where this book was created. Same for put, same for delete. We just do a pattern. We just do a flat map and check what kind of error, what kind of value we receive from the repository. Okay, if you want to work with Prometheus, there is also the integration with that, so you don't have to do anything. You just import the project and expose your endpoints to this, and then you will have the Prometheus format running in your /metrics endpoint, and you can apply this to be consumed by any tool you want. Okay, what if you want to add some middleware? So in some cases, we want to expose some public endpoints, but for some of them, we don't actually want to expose them. We don't. We just want to. We want to authorize and authenticate our users. So here's the example of writing a custom middleware. So in the custom middleware, we just pass some headers that will either say that someone is allowed to be entered the system, or fetch given resource, or not at all. And then we just wrap this those routes that we decided that we want to hide from not authenticated user inside of the middleware apply method. Okay. If we want to do a bit more advanced things, like maybe verify login, or retrieve some cookies for a given user, yeah, we can easily do that. So there is like project, I think it's called Crypto 37 or something like this, that allows you to generate tokens, so you can encode and decode your tokens and send them inside of your headers, and then you can again do the same with when you're receiving the request. You can decode them and see whether whether the header contained some specific cookie, whether it was like whether it allowed the user to fetch the resource or not at all. So it's all doable, and you don't have to write like a 20 or 30,000 line of code for just for this function. You have this working as the utility. Okay, so I bet you might already know this, but just a brief reminder that Chorus is like a cross-origin resource sharing. So it's like a mechanism that allows restricted resources on a web page to be requested from another domain outside the domain from the first resource was served. You can easily do this with you don't have to configure much if you want to have this in HTTP4S. You can define what you need, your policy, and then just apply this to chosen routes. Okay. When you want to test your code, we are lucky enough to have plenty of testing frameworks in the Scala ecosystem, so we can do this with specs. You can do this with Scala test. You can generate some like JSONs or other things with Scala checks if you want to test your decoding, whether your decoder or custom parser decodes everything properly, every possible sign, every possible combination. But you can easily do this with unit tests, because obviously HTTP4S comes with some other utilities that will allow you to make a clear and readable test code, so you don't have to again reinvent the wheel just to have this test working and checking your functionality. Okay, so is this the best solution that we can have? Some people might say yes, but I just wanted to point a few things. So in that example, endpoints and like definitions, paths, query parameters are tightly coupled to the server. They are not defined separately, but they are like, if you want to migrate from, for example, Akka HTTP to HTTP4S, or from HTTP4S to any other server, you will have to write almost everything yourself again. And writing this yourself might lead to many mistakes or many errors, which is not ideal because we want to avoid this. But the DSLs are different. The way how you define things in Akka HTTP and the way you define things in HTTP4S, it's completely different. So you would have to like refactor everything and rewrite everything. So these endpoints are not very reusable. You cannot reuse one thing in another, because if you think about things like security, if you think about things like error response, you have to define them each time separately, and it's impossible to integrate with docs. So you don't have any, working integration that will allow you to give the code on the input and then have the docs on the output. So for docs, there are like actually two possibilities. So we can either have YAML and have a pre-generated code. So there are projects like OpenSBT generator that allows you to have YAML as input. So you have to write YAML yourself. So you have to define everything, and then you can have server code. But obviously, it's not ideal, because I would not rely on the generated code in production system. And on the other hand, we have in some cases we have integrations that can generate YAML consumed later on by Swagger or any other thing by the code. But again, it's not ideal, because it's whenever you change this, you have to, whenever you change something in your logic, you have to change the and regenerate the whole YAML file. So here comes the pattern of declarative API and separating your API from actually the server implementation, to be precise. So we have a few options here: Tapir and endpoints4S, another library that allows you to do this, and typed API. In this talk, we will focus on Tapir. because I think it's one of the best solutions. So for me, like one of the most important things is that it's library, not a framework. So it does not dictate me how should I write my code. It easily integrates with what I have in my stack already. So it does not really matter whether I have HTTP4S, I have Zio, HTTP, HTTP. It will integrate with whatever I have. Obviously, it's maintained. So whenever you have, I think the company's name is Software Mill. So whenever you have a problem with that, you can talk to them. You can submit a pull request or solve the issue yourself and make a pull request, or create an issue that will be handled sooner than later, which is not very common for other libraries, unfortunately. And obviously, like Tapir is type safety, so like compile time guarantees. We don't have to think about all the stuff. It's declarative, so it separates the shape of the endpoint, so it separates the what from the server logic, which is the how. Can easily generate documentation, openAPI, Swagger, metrics as well, and this another layer of abstraction. So assuming that you have an issue of going from HTTP to HTTP4S, for instance, the first thing I would personally do if I would not have Tapir already, I would extract those endpoints to Tapir. I would rewrite those endpoints to Tapir, and then I would just change the interpreter. So it's way easier, because as I have the correctness in the first place, as I have this Tapir interpreted correctly to the HTTP route, it would be way easier. It would be like just one-liner change to have Tapir working with the HTTP4S interpreter. But we'll have a look at this in a second. So this is how Tapir works. You use the you define your base endpoint, where you can define your path, where you can define your error type. Obviously, you can add more things here. You can in the base endpoints, obviously, you can define maybe some security things. Maybe you want to add some token, or you can do whatever you want actually. And this is like quite nice, because then whenever you have your actual endpoint, you can reuse this base endpoint and define what kind of header it will have, what kind of JSON payload it will handle, what kind of HTTP verb it will use, whether it will be post or delete or maybe get. So that's quite nice. Once we have this, okay, so this is like another example that you can see. The other utility I want to point out here is paging. So you can define things like paging that will be reusable throughout your whole system. So that's pretty nice as well. And you can add some examples, which will be super useful when it comes to documentation and also description for the error. Okay. So yeah, here we have two endpoints that we'll use in our application later on. So we have the get endpoint that will show us all users, and we have get user that takes some ID of a user and then returns this user in a JSON. Once we have our endpoints defined, all we have to do is to provide, yet again, interpreter. So we have to provide a translation, a function that will translate the Tapir endpoint to actually HTTP4S route that we have seen at the beginning of this talk. We have to also provide the server logic. So again, we separate the definition, the how, sorry, the what with the how, which is server logic. So we define, okay, wrap this thing inside of the IO and do that, or maybe write something to database or invoke this service with these parameters. We can do all that without thinking whether we should whether we should use HTTP or HTTP4S at this point. And then once we have this endpoint and server logic coupled together, we can do interpretation. So that's what I've mentioned, translating from Tapir routes to HTTP4S routes. Once we have our translation, we can put those routes into our server. So we define our server the same way we have defined this previously, but instead of providing HTTP4S custom routes, we are providing routes that were computed thanks to HTTP4S interpreter. Okay. Obviously, if we want to add some security, we can define this within the with predefined method. We can unwrap some token. We can check this, and there is no issue with changing the effect type, because here we can see the future. So in previous example, we were using IO. Here it's using future because it will be most probably consumed by the HTTP server and the HTTP interpreter. Okay. What about testability? Tapir API can be easily again testable when it comes to unit tests. So we can use the Tapir stub interpreter that will stub a backend for us, so we don't have to think about how we gonna mock this. And then we send some. Then we create like HTTP request, and we will talk about HTTP in a second. And just create, once we have the request, the definition of the request, we use send using the backend stub. After that, as soon as we have this, we just map the response to check against some values inside of that. In this case, we make an assertion inside of the body of the response. Okay, so the nice things about Tapir, it's not just testability or type safety. It's one of the best things. But for me personally, I think the way how easy it is to integrate with openAPI or docs was super useful and was really shocking. So here, all we have to do, we have to add one liner. So we just define the previously we defined, for example, HTTP4S interpreter. But here we define openAPI docs interpreter, and we pass our endpoint or list of our endpoints, and we just provide some name of this YAML file and some versioning if we want. Same for Swagger. We can have both actually. So we don't want to just have documentation, but we want to also run our endpoints. So we want to pass our endpoints to HTTP4S interpreter, but also what we can do, we can use our endpoints and list of endpoints and pass this into Swagger, so we can expose this inside of inside of the same application. Just quickly, here's the example that does the same as the one from the previous slide, but it actually uses Zayo. So it doesn't really matter whether you use Zayo, or you use Akka or HTTP4S. The principles of using Tapir are mostly the same. Okay, just briefly we'll go through briefly entity decoders. So I bet the vast majority of people, especially that are working on the type level stack, are using CRC, but there are like plenty of options, including Scala XML if you work with XML files. But I hope you don't. Yeah, so CRC again is based on cuts, super easy to use. All you have to do is to define the right decoder. You actually don't have to do this. You can rely on CRC generic auto derivation, but I wouldn't do this personally, and I have suffered a few times, unfortunately. But yeah, as soon as you have this semi-auto in your model, it works out of the box in most cases. So for the API generation, I've mentioned that Tapir has this openAPI integration, but there is also async API that you can use. But we'll use openAPI in this example. Another great thing that we might use if we want to talk to another HTTP service, or we want to integrate with some API, is the STTP, which again comes from the software mill company. So things like it's maintainable, and all your requests are handled within short time frame. Applies again. With STTP, it works in a very similar way in terms of the dev experience, comparing to Tapir, because all you have to define is like your basic request with the method that it takes, URI that it will talk to, content type that it will pass. Maybe you can define some token. It's better in this case, and then you define your body and your response, how you want to handle your response. Once you have this definition, because again it's a declarative client, so once you have this declared, all you have to do is to create a backend, and again here we create a catch resource, and we just send this search entity with some parameters, some arguments, using the backend that comes from the async HTTP client FS2 backend resource in this example. Yeah, once we have this, again, STTP is super easy testable. You don't have to write lots of boilerplate for the sake of having your test, and you can easily use this for the integration test when you want to hit your endpoints and check whether your system, your application produces the correct value, correct JSON, or correct behavior. Okay, I talked briefly about observability. So Tapir can easly integrate with things like Prometheus, but it can obviously integrates with OpenTelemetry. I know that guys from Source Technology, they were hosting Łukasz from Scala C, and he was talking about Mesmer. Also, other very popular tool is Datadog, so it can also integrate with that. Once you define either your default Prometheus interceptor or custom interceptor, you have three default graphs that you can use and expose in your in your Grafana or Kibana dashboards. Okay, so this is the example of how you can build some custom metric, but it's all in the docs, so I won't bother you with going through that. Okay, so the stack I use for API layer and works nicely, and like all the pieces, all the puzzles fits together, is Tapir for HTTP4S and HTTP4S as the interpreter, Circe as my deserializer, as my entity deserializer and deserializer, HTTP when I want to talk to another HTTP server, Prometheus for metrics, and openAPI with Swagger. But yeah, as you have seen, there are like much more things that we could discuss in this talk. Even if we just narrow our discussion to the API layer, there are other protocols. There's like gRPC, there is GraphQL. Not everyone has to use REST. What if we want to use GraphQL? There are like 2 great libraries supporting this that I haven't mentioned. We didn't make any performance comparison, nor for the servers, nor for the clients, nor for the serializers. And also, like, there is, for example, Smithy that allows you to again generate some code out of the specification, so you don't have to work with this yourself. Okay, so that's all I had. I'm not sure how tight are we on time, because if we have a second, I just wanted to briefly show you some code.
Yeah, go for it. We've got plenty of time, Marcin.
Lovely. Okay, so I know. Talk is cheap. Show me the code. Hope you can see my screen and hope just the code is readable. So just briefly, I have like a simple project here. So some of the sub projects depends on the other ones, but yeah, just briefly, we have our model, which is book in this case. We have our definitions of the base endpoint. We have our paging defined. I bet you have seen this on the slides already. And yeah, two, 3 endpoints that are super easy to implement. Once we have our server, okay, let me restart this so I can prove it actually works. So what I did here is I have some server logic that talks to so the get books endpoint talks to book service get books method. The other one, get book, talks to, as you can imagine, book service get book with some ID. I also created some Swagger endpoints that I will expose here on under the docs, and I have also declared the Prometheus metrics just to show you that the integration works. And this is how I built my server. So let me, okay, so here is the Swagger. Let me refresh this. Okay, so here's the Swagger generated by the by Tapir integration with Swagger. So I didn't have to actually do anything, and I have like schema. I have all the basic stuff that your front end people might need to be able to hit that endpoint with some nice payloads. Also, like here's the Prometheus metrics. So if you have like something to consume those metrics, you can use this and put in your dashboard. You can add some custom interceptors, as I have already mentioned. You can do plenty of stuff with that. So this is the part of the code that describes those Prometheus metrics. If you're gonna have a look at the client, so another nice thing with Tapir is that you can have a client working like out of the box. So you don't have to do much. If you want, for example, your client to hit the same endpoints that you are defining in your application, it's easy to do with the HTTP client interpreter and the quick client. So I'll hit this endpoint with some value. Let's see if it will work. Okay. I hope you can see this. But the response was correct. So this is like the ID of the book, some title, and the year when it was written. And yes, you should be able to see this, that it was the endpoint was hit here as well. And yeah, last but not least, Docker files. Let me remove these two that I have created previously. So I don't have any Docker files, sorry, any YAML files or docs files. Sorry. Let me run that. So they should be created here. Yeah. We have those two formats, JSON and YAML, so we can again easily put them into Swagger or whenever we want to expose them. Okie dokie. So that's all I have for you today. So thanks for you who decided to spend this this hour with me. Thanks to all the OSS contributors that are making this great piece of technology that I can use. Without you, I would not be using Scala most probably. And thanks for all the like open source users, because like your feedback, I think makes the Scala ecosystem much more richer and way more better. And also thanks Francis and whole source technology group for having me and for inviting me for this talk today.
Thank you too, mate. It's been wonderful to have you. One question before we wrap up. So from Emerson Mora, they asked, is it possible to integrate it with the New Relic APM system? Could you provide an example?
Sorry, Francis, say again.
So can you integrate
the first part?
So the question is it possible to integrate it with a New Relic APM system? Could you provide an example? So I'm not sure specifically what that bit refers to, but yeah.
So I guess like the New Relic is the thing used for it's like a tool used for monitoring and debugging things. I don't know. I don't think so. Unfortunately, I don't think so. I don't think it's possible yet. I haven't done this myself for sure. So unfortunately, I think it's not possible at the moment. But maybe there is a way to do this. If there is a way, I'm happy to be corrected. But I honestly I don't know. I think that the answer is no. It's not possible at the moment. But maybe I'm wrong.
He was talking about observability.
Yeah. So if I'm like, this is like the monitoring tool. I think it's not possible at the moment.
Fair enough. Are you able to send the the samples? Obviously, we will be sending out a recording. We do that on our YouTube channel anyway. But will you be able to send through the notes as well?
Yes, sure. So like if anyone wants to like reach out to me, there's like it's like my Twitter, GitHub, and LinkedIn. So like I'm happy to, you know, like the presentation is hosted on GitHub already. But if you have any questions, just give me a shout. I'm answering every single message. So
cool.
So just so it's all there.
I think that's everything. So look, have a great evening, everyone.
Frank, I'll have one more question. If I can have one request, there was like a little questionnaire where I ask like whether you fancy the talk or not. If you can scan this with QR code with your phone and like give me the honest answer, like anyone on the call who's here, I'd really appreciate this. I'd be like really I'd be really happy to see whether like what people think about this. So
perfect. Will the code be on the notes that you send around as well?
Yes.
Perfect. So unless there's any further questions, I think that is us all done.
Lovely.
Perfect. So we'll wrap up now. Thank you again for presenting, Marcin. It was a great talk. And we will send out the notes along with the YouTube video of the entire talk to everyone on the Meetup group. Thanks very much, guys. Have a great night.
Cheers, guys. Appreciate it.
Cheers. Bye-bye.
Bye.